Okay, our first problem, we have a vector which we designate with V. The arrow over the top indicates that we have a vector, and that vector is a velocity vector, which is a 12 meter per second velocity at 37 degrees. Now the 37 degrees is measured with the positive x-axis, measured from the positive x-axis, and the 12 meter per second is called the magnitude of the vector. We want to find the x and the y components of this vector. It helps to draw a picture. We'll draw an x-axis here and a y-axis here, and at an angle of 37 degrees measured counterclockwise from the positive x-axis, and that's how we always measure vectors. We have a vector whose magnitude is 12 meters per second. Now this vector is drawn to some scale where 12 meters per second is compared with a 1 meter per second scale. It'll be 12 times as long as a 1 meter per second. So implicitly 1 meter per second might be indicated by this distance on the x-axis, same distance on the y-axis. The x component of any vector, and if you know the trigonometry, you know the circular definition perhaps, where the x and y components are the x and y coordinates of the vector, of the end of the vector if the initial point is at 0, or the opposite side and the adjacent side of a right triangle. Either one of those suffices, but you don't really have to know that. Physics 121 students might not know that, and I'm just going to assert that the x component of a vector is equal to its magnitude, in this case the 12 meters per second, times the cosine of this angle, cosine of 37 degrees in this case. And to do the cosine of 37 degrees, you just make sure your calculator's in degree mode, enter 37 and then cosine, or depending on the notation, cosine and then 37. And then you multiply that by the 12 meters per second and use your calculator in whatever manner it's to be used. And we then end up with 12 meters per second times 0.8, 0.8 being the cosine of 37 degrees. Okay, and to review, for those of you who've had trigonometry, and perhaps give a little bit of an explanation to any Physics 121 students who haven't, the 37 degrees is the angle with the x-axis, and the cosine of 37 degrees is just the ratio of this side to the hypotenuse. This is called the side adjacent to the angle. It's the adjacent side divided by the hypotenuse, so that this side will be equal to that proportion of the hypotenuse. So in this case, at 37 degrees, this side is 8/10 of the length of this side. So we have 12 meters per second times 0.8, or 9.6 meters per second. That's the x component of this vector. The y component is obtained by just taking the magnitude of the vector and multiplying it by the sine of this angle. The sine is another button on the calculator for those who don't know. And the sine is just the ratio of this side to this side. Alternatively, can be thought of as the proportion of this side that you take to get this side. And that gives you this vector. Now these lines here we call projection lines. This line projects down to the x-axis at a right angle. This line projects straight across to the y-axis at a right angle. And this vector starts at the y-axis and moves over to the projection point here. This one starts at the x-axis and moves up to the projection point here. The bottom line is that the y component of this vector is 12 meters per second times the sine of 37 degrees, that's this component, which is 12 meters per second times 0.6. The sine of 37 degrees is 0.6, which means that if we have this kind of a triangle with 37 degrees here, this side is going to be 6/10 of this side. 6/10 of the 12 meter per second magnitude of the vector is 7.2 meters per second. So that gives us our x and our y components. The interpretation of this as a velocity vector, if we regard the green circle as the object that's moving at 12 meters per second at 37 degrees. If we have another object directly below that one, moving at 9.6 meters per second, then this object will always remain directly below this one. So these two objects, wherever, this one will go along here in this direction, but they'll always go in such a way that this object remains directly below this one. And similarly, you have an object moving, let's say, upward in the y direction at 7.2 meters per second. It will always stay directly across from this object as it moves at 12 meters per second at 37 degrees. So we call the velocity of this the x component of this velocity. This is the y component of this velocity.